Alright guys, so today we're going to talk about similarity, and we've already talked a little bit about similarity in the context of dilations back in chapter 4. So we're going to refresh that, talk about scale factor again and all those things, and then we're also going to talk about how do you find missing sides on shapes that are similar. So first thing, we need kind of a working definition of what it means to be similar. So the first thing we need is that corresponding angles are going to be congruent. So, corresponding angles are congruent. R-U-E-N-T. Goodness. All right, there we go. That says congruent. Yeah. So, that means that if we're looking at it in the context of these two triangles right here, that maybe we can see, there we are. First off, if triangle ABC is similar to triangle DEF, remember that little squiggle means similar, or is similar to. The angles that are considered corresponding or going together are going to be the ones that come in the same order. So first off, angle A is going to go with angle D, so we can say angle A is congruent to angle D, and that's already labeled for us in the picture. Angle B is congruent to angle E because that's the second letter, and that's also already labeled for us in the picture with kind of an older symbol. We're going to change that to 3 little arcs. And then lastly, angle C is congruent to angle F. And that's also something that's labeled for us already in this picture. So that's the first thing of what it means for two shapes to be similar, which now, we're looking at that and going, okay, well, that's the same as when they're congruent, right? So the difference here is that for similarity, the sides are not going to be the same, right? This one's clearly larger than this one. So what we say instead for the sides is that corresponding sides have the same ratio, or they are proportionate. Alright, and so what we mean by that is if I were to put the sides that go together in a ratio, it's going to be the same all the way across. So, we're going to start with the first two letters are AB, so we're going to put those on top, and AB goes with DE, so DE on the bottom. Then we're going to keep going here. We've got BC are the next two letters. BC is going to go with EF. And then lastly, AC, the first and last letter, DF, the first and last letter. Okay, so all three of these ratios are going to be equal. And so the important thing to note also, you can flip all of these ratios, but you have to flip all of them if you're going to switch them up. All the ones from one triangle have to be on the top, all the ones from the other triangle have to be on the bottom. All right. But what we can do is then take what we have on these sides here and fill in these ratios. So I'm going to set up 3 more ratios, but we're going to fill them in with whatever number or letter is written on the side. So for instance, AB was 15, so we're going to put 15. DE was X, so we're going to put X. And then BC is 10. EF is 4, AC is 5, and DF is 2. Okay, so a couple of things with this. First off, one way that we could solve for this missing X, yesterday we learned all about solving ratios and proportions. We could take this one, kind of pull it off over here. 15 over x equals 10 over 4, and we could solve this. So I'm going to, cross multiply, so we got 15 times 4, which is 60, and then x times 10, which is 10x. And then divide by 10 on both sides, we get 6 equals x. So that would be that missing side. So that's one useful thing we can do, knowing that two shapes are similar to each other. We can solve for missing sides that way. Another interesting thing here is we can talk about the scale factor. The scale factor you can find by just picking any of the ratios that are filled in with two numbers. So the scale factor is a filled in ratio. For example, on this one, you could use 10 over 4. You could use 5 over 2. Those are the same thing because 5 over 2 is what 10 over 4 reduces to. So that would be the scale factor. You could also flip it over, and that would be the scale factor. And the way that you use them will be different depending on what you're trying to find. So 2/5 could also be the scale factor between these two shapes. Using the scale factor is another way that we could solve for this missing side. And sometimes it will be easier to do it that way, and sometimes it will be easier to do it this way. So it really depends on what you're trying to do. What you would want to do if you were going to solve for the missing side using the scale factor is, so we'll kind of go the other way that we could solve this. You take the side that goes with it that you know. So like since I'm trying to find DE, I would use AB because I know those go together. And then you multiply it by the scale factor. But which one do you choose? Because you get something different if you multiply by 5 over 2 versus 2 over 5, right? So here's what you would want to do. If you're trying to make it smaller, then you need to use the smaller scale factor. If you're trying to make it bigger, then you use the bigger scale factor. So between these two numbers, which one is smaller? 2/5. Since I want to make 15 smaller and get it onto the smaller shape, I'm going to go 15 times 2/5. And 15 times 2/5 is 6. So that's just another way to find that x is 6. All right. Either way of doing that will be fine though, as long as we can figure out that missing side. We just have more than one way to do it now. Okay, so that's kind of the idea behind similarity. The next thing we're going to do, we're going to go through a couple of examples of solving for missing sides using similarity. So, here we go. All right, for our first example down here, it's really kind of more like our second example, I guess, at this point. But anyways, we're going to start with, we need some information about this picture. We're going to be told that triangle ABC is similar to triangle PQR. And we're going to be asked to find PQ and PR. Okay. So the first thing that I would probably do in a situation like this, since I don't have anything on those two sides, I'm going to label them with an X and a Y, just so that I have something to solve for here. But another thing you could also notice, we wouldn't necessarily have to be told that these two are similar, because notice it already shows us that A and P go together. It shows us that B and Q go together and are the same. And if these two have matching partners over here, then these ones will also match. So we could figure it out that way, but we could also be told a similarity statement. Anyway, sorry, sidetrack. So step 1, set up the ratios. Since I have 3 sides on each triangle, I'm going to need 3 ratios, kind of like we had on the problem up above. So we're going to have something that looks like this. Okay, so starting with AB. AB goes with PQ, so we're going to have AB over PQ. Next one, BC goes with QR. Last one, AC, goes with PR. All right, so now we have our 3 ratios all set up. The next thing we want to do is fill in our ratios with given info. So what we mean by that is we need to take all the numbers and letters and put them into our ratios. So AB was 4, so we put a 4. PQ was X, so we put an X. BC was 6, so we put a 6. QR was 12, so we put a 12. AC was 7, so we put 7. And PR was Y, so we put Y. Okay. At this point, you've got some options. You can either figure out the scale factor and solve it using the scale factor, or you can set up some equations and solve it using equations. Either way is totally fine. One thing I would have us notice to start with, though, is 6 over 12. That's our only filled in ratio. That's like completely filled in with no letters. That's going to be our scale factor. 6 over 12 is the same as the fraction 1/2. If you flip that fraction, you get 2. These would be our scale factors. Oops, can you see that? Maybe. There we go. So if you want to use the scale factor to solve for the missing sides, you can. And it's this one, it might be easier to do it that way, right? Because 6 times 2 is 12, 4 times 2 is 8, 7 times 2 is 14. So sometimes when you have a nice, easy to work with scale factor like this, you can do it that way, and it's much easier. But sometimes it helps to actually set up the equations and things like that when you, especially if you have a scale factor that's a little bit different or less easy to see what's going on. So I'm going to show the setting up the equations way also. All right, the equations that we're going to set up, we're going to take 4 over x and equal it to 6 over 12. So we're just going to pull off this one to start with. And we'll solve that equation. 4 times 12, x times 6, divide 6 on both sides, and we get that x is 8. So the question that we were asked to answer, though, since x is 8, PQ is 8, is what we want to write. All right, and then our other equation that we could set up, we're going to do the same thing with 7 over y. We're going to equal it to our scale factor, or our, you could also use 1 over 2 if you want to, or the ratio we have here, 6 over 12. Going to multiply, 7 times 12, 84, equals 6y. Divide 6. We get that y is 14, so that tells me that PR is 14. All right, so now we've seen a couple of different ways that we can find missing sides of triangles using ratios and similarity. The next one we're going to try, we're going to look at when a shape has more than 3 sides, because this works for any shapes that are similar to each other, not just triangles. So let's go ahead and do one of those on the next page. Okay, so for more than 3-sided shapes, we're going to have to actually draw some shapes here. So we're going to say we've got this shape, ARHS, and then BWST. And we're going to start with the similarity statement that ARHS is similar to BTSW. We're going to be given that this side is 9, this one is 6, this one is 20, this one is 12, and this one is 16. and we're going to be asked to find the missing sides. Okay, so this one works the same exact way that the triangles one did. It's just that now that there's 4 sides, we're going to need to have 4 ratios, not just 3. So, step 1, I would take all the missing sides and label them with like X, Y, Z, so that I have something to put into my ratios. Then we're going to go and set up our ratios. We've got 4 of them we need this time. Okay, so with 4 ratios, we're going to start with AR, and BT goes with it. The next 2 letters are RH. The next 2 letters here are TS. Go ahead and pause the video real quick and fill in the rest of the ratios here. Okay, hopefully you tried that and we're successful here. If you want to check your answers, we've got HS on the top of this one, SW on the bottom, and then AS on the top, and BW on the bottom. Okay, step 2. We're going to take our ratios and we're going to replace the letters with numbers. And sometimes letters like X and Y. All right, so I'll do the first one. AR is 6, BT is Z. Go ahead and pause for a second, try filling in the rest of the ratios, and then come back and check your answer. All right, hopefully you did that. We should get Y over 20, X over 16, and 9 over 12. Okay, so if we're looking for the scale factor here, this one's going to be our scale factor. It's the only one that has both numbers filled in. 9 over 12 is equal to 3/4. So this would be our scale factor. And if you're doing it the multiplying way, this would be the one that you use to go from big to small. If you flip it and you get 4/3, this would also be considered a scale factor. And it's what you would use to go from small to big. So if you want to do it the multiplying scale factors way, you can. Or if you want to do it setting it equal to a ratio, you can do it that way. That's the way that I'm going to show next. So since we've got 3 things that we're trying to solve for, we're going to need to set up 3 equations. And we're going to set them all equal to the scale factor. You could use 9 over 12 if you want to, but you can also just use 3 over 4. So that's what I'm going to use this time. So I'm going to take the first one, 6 over Z, and I'm going to equal it to 3 over 4. My second equation I'm going to set up, we're going to take Y over 20 and equal it again to 3 over 4. And then the third equation, we're going to take X over 16 and equal it to, again, 3 over 4. Okay, so pause the video here, take a minute, and try solving all 3 of these equations. And then unpause it, come back and check your answers. Okay, hopefully you did that. Here's how it would go if we do it correctly. We cross multiply here. We've got 6 times 4 is 24. 3 times Z is 3Z. Divide 3. And we get that 8 is Z. And Z went with BT. So if we look back up here, BT was Z. So that means that that one is 8. So that'd be part of our answer. All right, doing the same thing here. 60 equals 4y. And then divide 4. So y is 15. And so then if we look at where y was, y was HR, so HR is 15, or RH. All right, and then our last one, cross multiply, 4x equals 48, divide 4, x equals 12, and if we look back at our picture, x was on HS, so HS is 12. All right, and that's pretty much it for today. So that's using similarity to solve for missing sides. Hopefully this was helpful. We will continue going over this more next week, but for now, that's all we got. Have a great day.